Artificial Intelligence and Sensors Better Together, an automotive presentation by Rendered AI. When machines can see information in the sensor data that humans can't, there is an opportunity for greater autonomy, safety, and understanding. In other words, machines see phenomena from your sensors that are invisible to you. And that's a good thing. Bad things happen when we use artificial intelligence without good data. You are all aware of the Tesla in Taiwan incident. This is on a clear day with a very clear line of sight, but the software on board had never seen an overturned truck, so it didn't know to brake. This is not a failure of software as such or a lack of coding that resulted in this crash. This is a lack of data. The limitation here is that the data that was used to train these algorithms didn't include an overturned truck. What if we could generate all the data we wanted on demand and didn't have to wait for this to happen? This is what the synthetic data revolution is all about. Researchers in machine vision and data scientists are spending 80% of their time or more just managing data. The best practice of today is to have multiple companies and with multiple humans label data and compare results, and sadly, those results still underperform. If you want humans to distinguish between a tree and a person, that is relatively easy. But if you want them to distinguish something about vibration and how that is going to show up in a vehicle's radar signature, that is something humans do not do well. The key takeaway here is that by knowing the sensor characteristics, creating synthetic data and labeling, training, and cold start based on those characteristics and other physics, outcomes are improved and data management time dramatically decreases. The next issue we run into is the cold start problem. And in many respects, that is what this conference is all about. Buy a new sensor, have a new cold start data problem. How do you do next generation AI engineering when there is no field data? Hopefully, new sensors have new capabilities. Upgraded sensors have different characteristics, and new systems have new signatures. So new data sets must be built, and simulations are often the only way to do that. And finally, often the data we would be using to machine train is restricted, classified, proprietary, or otherwise inaccessible from a supplier. We see this in government and where PII is important. Welcome back. In part 2, we will look at the most common application areas for rendered AI both in and out of automotive. How in the context of next-generation systems engineering do you do A/B comparisons? Whose radar are you going to integrate into the car when what you care about is not the bandwidth or the noise figure of the radar, but what you really care about are the AI outcomes that will be driven by the new sensor? Sensors are the lifeblood of AI. It is one thing to take an existing system into the field and gather data. It is quite another problem to evaluate a component in the middle of a 5-year development cycle. I mentioned the rare events and edge cases and how we help mitigate risk. However, humans are infinitely inventive and the world moves on. Both forces create new edge cases. We will never be finished with rare events. It is the very nature of change. The way we have built our tool helps drive a process by which we can deal with unexpected but possible phenomena. In our workflow, one of the outcomes is not just how good is our model, it is about how well does it generalize. If you train on a certain set of domains, you want to be able to build another data set where you also know the ground truth to understand if your model is capable of generalizing between those two. This is where what-if scenarios and experiments become important. And finally, active learning is the recombination and automation of these tools in new ways to solve emerging problems in autonomy. By way of example, if you have sensors at the edge where algorithms are running, how do you keep them up to date? How do you identify problems? How do you communicate enough data back that you can address the confusion without spending the time and experiencing the latency of massive data collection efforts? In a concept, we are sending back metadata, not the full imagery, but metadata regarding those uncertainties and circumstances of failure. The data sets then can be reconstructed synthetically via simulation. Welcome back. In part 3, we will look at synthetic data and workflow. When you look at tools that are often used in synthetic data, we most often see tools that were created for another industry. Unity was built to produce video games and is very biased toward visuals. Another approach is GAN, whose weakness is generating data outside the domain you already understand. And if you do produce an image in either, and there is something you don't understand about the interaction, you don't have the physical ground truth, we assert it is important to simulate the physical ground truth in order to get to provable outcomes and make the connections that are necessary. The physics are important to us so we can create realism. Realism is crucial, but derived from realism is the next point, which is even more important, and that is traceability. GAN-based photoshopped images and just ray tracing alone cannot deliver root cause traceability. Here is an example of our synthetic aperture radar work. With a physics-based approach, we don't just get the image, we get the raw data and the raw collection that led to that image. And so if we see strange effects, we can relate it to the sensor's particular degradation mode and trace that to what is physically happening in the environment. That helps us to establish ground truth, which is the baseline for explainability and provable outcomes. Proving means we must do experimentation, traceability, and what-ifs. Workflow is not about productivity, although that is important. Workflow is about AI proving, experimentation, test, and feedback that quantify our gaps in understanding are exposed with workflow. This slide is a high-level view of our workflow. The closed-loop nature of our workflow accelerates the pace to which we get to explainable and provable outcomes. Our objective as a company is to get all these capabilities into an open, easy-to-use tool. It is not just about the simulation capabilities. In fact, that is a small but important part. We provide 3D model libraries, new model generation capabilities, procedural generations to allow us to do world building on the fly, and domain transfer tools that will help us match the sensor-specific characteristics to various domains. We provide both a graphical and API interface into our tools. Rendered AI is a product company. We provide services and consulting to make your organization successful and independent. We are looking for partnerships to further develop this approach. For more information or for a product demo, please reach out to us at rendered.ai. And thank you.